Good afternoon and welcome you all. I am Selvagan, simulation engineer. I would like to extend a warm welcome to everyone for EGS webinar. We are delighted to have you here with us. Your presence adds a great value to our meeting. And thanks for joining. We will start with the overview of who we are and what we do. EGS India does engineering services, 3D CAD software selling and FEA service since 1993. We have implemented PDM and PLM to many of the customers. We have 3 branches in which Chennai is our head office and sub-branches in Coimbatore and Trichy. Solidworks we well know software in market, in which we are one of the leading resellers in Tamil Nadu. Our vision is to create a better engineering solutions by collaborating. Our mission is to give a better technical support which includes software solutions, new product development, and so on. And our legacy started from 1981 in US, and later on our Mr. MD or Natarajan started out operating at 1993 in Chennai as engineering service for OEMs. And expanded for academics training and 1996 moving forward, as well as known FEA software Cosmos has been represented by EGS India, which has later acquired by Dassault Systems, which is now Solidworks Simulation. As many of the customers are using it in 1999 EGS, we partner with Dassault Systems as a technology partner for Solidworks in India. And then we have expanded our operations to support our customers at Coimbatore in 2007 and Trichy in 2009. And we have moved to our own building in 2011 at Kodambakkam as head office. We are supporting the customers for past 3 decades. We move 140 plus associates to support our 1500 plus customers across India with consistent year-on-year growth. We are affiliate members of ACAE India, IPA and other industrial categories. We have separate predefined team for each and every process. For software solutions, business development, technical support and services, data management implementation, software development, marketing, engineering services, academic training, and human resource and administrators. As I mentioned earlier, we are one of the oldest partners of Dassault Systems for Solidworks in India, and this year we are stepping into 25th year in association with Dassault Systems. We are number 1 partner for technical support in India as rated by customers' feedback. Overview of Dassault Systems. 22,000 people are working passionately across globally with 69 R&D centers. In India, the R&D center is located in Pune. Solidworks has 3 million commercial customers with 25 million across 140 plus countries, serving more than 12 industry verticals. And what we do in EGS. Engineering service like new product design and development, design validation, value engineering, PDM PLM support, and implementation. We have done it for customers like FL Smith, Flextronics globally. We also do software customization and automation using APIs. In software solutions, we provide Solidworks simulation for manufacturing industries, 3D Experience Works, which is the latest version of Solidworks with basic PLM functionalities where many of our customers are using. We provide logo press for customers who are in die design, sheet metal, nesting and blanking. We also provide a segment for tolerance stack-up analysis. Through our academics division, we provide a technical training on CAD, CAM, CAE for engineers to hone their skills. We also provide training on ED&T, FMEA, DFM and DFI. Why EGS? A proven product design and development experience for customers worldwide, documented BSQ process to transform the ideas into the real-world products, dedicated engineering teams, established business process and organization structures. With the automotive OEMs across the passenger commercials, off-road vehicles, we have a good experience with it. Once again, good afternoon everyone. Today we will explore how Abaqus CAE handles the material failure through Element Deletion. This is a powerful tool for simulating the fracture and damage in real-world engineering problems. This topic is very important for failure modeling, fracture simulation, impact analysis, crash simulations, metal forming and damage problems. Abaqus CAE is a part of the similar portfolio developed by Dassault systems. Abaqus CAE is a powerful finite element analysis software used to simulate the real-world engineering problems. It helps engineers to predict the product behavior before physical testing, reducing development time and cost. The software is widely used for nonlinear complex and advanced engineering simulations. Abaqus CAE allows users to create a basic geometries directly within a software using sketching tools such as lines, arcs, and rectangles. These sketches can be converted into 2D or 3D parts using operations like extrusion, evolution, and sweep. Import geometry also can be done with the Abaqus CAE. Other CAD files directly imported in the Abaqus CAE for the analysis. Complex models created in CAD tools can be imported. Abaqus supported common file formats such as STEP, IGS, ACIS, and Parasolids. And other CAE softwares like Hypermesh, that type of output formats also can be imported in Abaqus, and directly we can go for a post-processing. In Abaqus CAE, the materials are defined by specifying mechanical, thermal, or other physical properties required for the simulation. Common properties include Young's modulus, Poisson ratio, density, and plastic behavior. Abaqus supports a wide range of material models such as elastic, plastic, hyperelastic, viscoelastic, and damage models. This allows engineers to simulate the realistic material behavior under different loading conditions. Meshing is the process of dividing the geometry into a small finite elements connected by nodes. These elements help the software numerically solve the complex engineering problems. Abaqus CAE provides different element types and mesh controls such as tetrahedral, hexahedral, and structured or free meshes. These elements type is selected depending on the geometry complexity and analysis requirements. We have two different portfolios in Abaqus CAE, which is Abaqus Standard and Abaqus Explicit. In Abaqus Standard, the advanced simulation capabilities, some key simulations capabilities included structural analysis, thermal analysis, dynamic analysis, contact simulations, damage and fracture modeling. In Abaqus Explicit, it is well known for handling the complex nonlinear problems such as material nonlinearity, large deformations, contact interactions, damage and fracture behavior. That's why it's widely used in advanced research and high-end engineering analysis. Wide industry applications of Abaqus CAE is used in many industries. Automotive for crash simulations and durability. Aerospace for structures and fatigue analysis. Energy and pressure vessels for stress and thermal analysis. Manufacturing for forming and machining simulations. And we will dive into the topic of element deletion. Element deletion means removing the element from the mesh during the simulations when a failure criterion is met. The element stiffness is reduced to 0 once deleted. It no longer carries the load. It is removed from the stiffness matrix contribution. It simulates the crack growth or material failure. How it will help to simulate the crack initiation and crack propagations in structures. As stress increases near the crack tip, the element fails and are removed, allowing the crack to grow naturally in a simulations. This is widely used in fracture mechanics studies. The simulations show the damage localization near high stress regions. The crack grows as damage evolves in the material. Abaqus damage models help the predict fracture path and structural failure. Metal damage models uses for metals, large plastic strain, impact problems. Shear damage model uses for sheet metal forming, cutting simulations. Damage evaluation energy is used for displacement-based softening behavior. Jones Hoop damage models very popular in high strain rate plastic impact crash simulations. Jones Hoop model is a structural material model. It's widely used to simulate the behavior of metal under high strain rates, large plastic deformations, and high temperatures. In this paper, we will fully explain this model, which is implemented in Abaqus explicit solvers. Based on our experience in finite element simulations, this model is particularly effective for impact analysis, plastics, and machining simulations. And we use the Jones Hoop damage model for this demonstration. I will demonstrate the concept of the material deletion in Abaqus CAE using an orthogonal cutting is a simplified machining model where the cutting edge is perpendicular to the cutting direction. It's widely used in the research to study the chip formation, tool wear, and cutting force. Why the separation matters is physical experiments are costly and time consuming. Abaqus allows a visual testing of multiple cutting speeds, tools, geometries, and materials. This helps to guide the industry in tool design and process optimization. In Abaqus itself, we can create the tool and workpiece. In Abaqus, we can create the 3D model from 2D to 3D creations with the dimensions. Model as a rigid wedge with a defined crack angle. Cutting edge sharpness is critical into the fine definition in geometry. And we can create the workpiece, a rectangular box dimension chosen to represent a small section of this material is sufficient to avoid the boundary effects. This is how we can create the tool and a workpiece in an Abaqus interface. Next, we will go into assign the materials. We will apply the material property to the workpiece. The workpiece material model is used the Jones Hoop as I already mentioned in the last slide. It's a plasticity model accounts for strain, hardening, strain rate, sensitivity, and thermal softening. Input parameters like yield strength, hardening modulus, strain rate, constraints, and thermal coefficients. And also we will assign the density to the model. Tool material, it will be the rigid but can be elastic with a very high stiffness in a thermal effects or study. Next step, we will assemble the workpiece and the tool in a correct position, cutting position. The workpiece and tools were imported, created as separated parts. They were assembled in Abaqus CAE to replicate the actual machining or forming configurations. This assembly ensures the correct positioning on align before applying the loads and the boundary conditions. With the help of the mates we having in Abaqus CAE, I just position the correct format of the tool and workpiece. We are defining the dynamic explicit step to capture the high speed tool workpiece interactions. In this method, we will define what type of analysis we are going to run. Explicit dynamics is chosen because it handles the complex contact and large deformation effectively. Mass scaling is applied to improve the computational efficiency without compromising accuracy. A mass scaling setup is a definition to create the target time increment of 1 × 10⁻⁴. This ensures the stable time increment while reducing the total number of increments. Next, we will create the output request. The field outputs are configured at 20 intervals through the step. This provides the clear record of stress, strain, displacement, and contact variables over the time. The interval settings ensure the manageable data size while capturing the evolution of results. The importance of the mesh. Next step will be the mesh module. In cutting simulations, the mesh is more and more important. By creating a best quality meshes directly impact the accuracy of stress, strain, and temperature predictions in orthogonal cutting. Cutting involves a high gradient near to the tool workpiece interface. In Abaqus, enabling the element deletion allows the element to remove once they reach the critical damage criteria. This is essential in cutting simulations to realistically represent the chip separation and material removal. For the tool, the cutting edge of the tool and immediate contact zone of the workpiece. Use partitioning of the workpiece geometry to control the mesh distribution. Now we are creating the interactions between the workpiece and the tool. The accurate interaction setup ensures the realistic cutting forces. Define a contact pair carefully between the tool and workpiece surfaces. Friction coefficient directly influences the chip formation and heat generation. Use experimentally validated values for variability, thus giving a friction coefficient and normal behavior. Enable the element deletion in the interactions to simulate the chip separation. This prevents the disordered elements from remaining in the mesh. The next step will be the boundary conditions. The workpiece constraint. The workpiece is fully fixed in all 6 degrees of freedom. That is, translation plus rotation will be arrested. This ensures no unwanted displacement or vibration during the cutting. There will be the tool will be motion in a U1 direction, and we give a boundary conditions like a pre-described displacement of 0.08 units representing the cutting stroke in a tool movement direction. Next step will be the job. We will submit the job by creating a job in Abaqus CAE and using the CPU for post-processing. The simulation was run using the parallelization across 8 CPU cores. This reduces the computation time and improves the efficiency for large nonlinear cutting problems. Parallel executions ensures the faster convergence while handling the highly refined mesh and deletion enabled element. The post-processing provides the key results like stress, displacement, reaction force, and acceleration. With the help of the animations, we can exactly check the behavior of how the tool removes the chips from the workpiece. The critical for stakeholder presentations to visually demonstrate the cutting behavior. Stress contours high strain zones near to the tool tip. Where the tool is fitting as the exact face of the workpiece, the stress will be increased in the particular phases. The reaction force provides the insight into the machining loads requirements. Animations plus plots together give the commute pictures of the process physics. Also, with the displacement contour plot, we can exactly capture how the tool is moving from the one position to another position. This can be plotted in XY plots for quantitative analysis and animated for dynamic chips formation and visualization. Applications and advantages of element deletions enables the realistic simulations of damage and fractures, predicts the material failure and fracture behavior accurately, Simulate the real-world behavior under the extreme loading conditions. Improve the product safety and reliability through virtual testing. Reduce the physical prototyping cost and testing time. Enables the better understanding of damage provisions in materials. Enhances the crashes, impact and forming simulations accurately. Accelerate the decisions making in engineering and design process. The key takeaways will be element deletion simulates the material failure. It requires damage initiation, damage evaluation, mostly used in explicit analysis. MES plays the critical role. Element deletion analysis helps the engineers to understand how material behave under extreme conditions and enables a better product design before physical testing. This is how we can predict the behavior of the workpiece under the tool removal process. Different tools to check and analyze the realistic condition in a real-time scenario to virtual testing without spending a lot of investment in a prototype manufacturing. And thank you for all joining today's session. We hope the insights shared will support your journey with our solutions. For any further queries or clarifications, please feel free to reach out to our Aegis marketing team. We will be glad to arrange a one-to-one interactions to address your specific requirements.